So the vertex form is y equals a times x minus h squared plus k. It is called the vertex form because the vertex is located at h, k. Now we're going to go over what each one of these values represent. The value of a, if it is positive, it will make the parabola facing up. If it is negative, then the parabola will reflect across the x-axis and it is going to be upside down. So you can think of it positive, happy face, negative is a frowny face, it's upside down. Now also the value of a, if it is greater than 1, it is going to stretch the graph, so it's going to be narrower. So it's going to stretch it. When the value of a is between 0 and 1, it gets wider. So we say that it compresses. So compress. So it stretches and it compresses. Now the value of h, that one moves the graph to the left or to the right. It is a horizontal translation. Horizontal translation. And the value of k, that one moves the graph up or down. So it is a vertical translation. Make sure that you write this down, as you will be seeing these letters later on in different functions, and every time that we transform a function we will be seeing h, k, and a, and they represent the same thing. They represent horizontal translation, vertical translation, and also the value of a will reflect the graph across the x-axis. Okay, so here's the graph of the parent function, and we're going to graph now y equals x minus 1 squared plus 2. And I'm going to use the table of values of the parent function as a guide. And let me use another color so you can see what I'm going to do. Okay, the value of a in this case is 1. And if there was another value here, I will write it right in front of the y. I'm going to write the 1, although it doesn't make any difference on the value. The value of k affects the y, so it's going to go right here. Now the value of h affects x, so it's going to be plus 1. And yes, it is plus 1. It is always the opposite of what we have here. So if I have a negative 1, then here is going to be plus 1. If this one was a positive, here it would have been a negative value. It is always the opposite. Then we're going to use this table of values to evaluate each one of these ones. So this is what we're going to do. So we will have negative 2, because this table of values begins with a negative 2, plus 1, negative 1, plus 1, 0, plus 1, 1, plus 1, 2, plus 1. On this side, it's going to be 4, because I have a 4 here, plus 2, 1 plus 2, 0 plus 2, 1 plus 2, and 4 plus 2. Okay, again, this is what I have on the table of values for the parent function. I write it down here and I'm evaluating it with a plus 1. And then I'm adding 2 to each one of them. So let's go ahead and write what I got. So negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. On this side, we will have 4 plus 2 is 6. 1 plus 2 is 3. 0 plus 2 is 2. 2 plus 1 is 3. 4 plus 2 is 6. So those are the points that I'm going to plot here. And let me select a darker color. So we're going to have negative 1, 6, 1, 2, 3, 4, 5, 6, 0, 3, 1, 2, 2, 3, and 3, 6. So my new graph is going to be, doesn't look pretty, but that's how it's going to look like. Now we're going to go ahead and graph another one, but we will have a value in front of the x minus 1. So that means the value of a is not going to be 1. We're going to graph now y equals 2 times x plus 1 squared minus 4. So again, I'm going to have my table of values, x and y. Now, this value, the one in front of the x plus 1, which is the value of a, will go here in front of the y. This one is going to go here. And this one goes here, but it's always the opposite, so it's going to be x minus 1. So now, on my original table of values, I have negative 2, negative 1, 0, 1, and 2 for x. So negative 2, negative 1, 0, 1, 2 for x. And for y, I have 4, 1, 0, 1, 4. 4, 1, 0, 1, 4. So it's going to be negative 2 minus 1, that is negative 3. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1, that is 0. 2 minus 1, that is 1. Now let's take a look at the y. So we're going to multiply each one of these ones by 2 and then minus 4. So 2 times 4, 8, minus 4, 4. 2 times 1, 2, minus 4, negative 2. 2 times 0, 0, minus 4, negative 4. 2 times 1, 2, minus 4, negative 2. 2 times 4, 8, minus 4, 4. Okay, so let's go ahead and plot those points. So it's going to be negative 3, 4. And I'll use another color. Let me use black this time. So again, it is negative 3, 4. 1, 2, 3, 1, 2, 3, 4. Then my next point is negative 2, negative 2. Negative 2. Hi, negative 2, negative 2. The next one is negative 1, negative 4. Negative 1, negative 4. The next one, 0, negative 2. 0, negative 2. And the last one, 1, 4. 1, 1, 2, 3, 4. Hi, this doesn't look good. Okay, let me redo this. Kind of, sort of. And that's the graph. It is not very clear, but it is, if you notice, it's a little bit narrower because the value of a is greater than 1, so it is stretching, so it's getting slimmer. So unlike the other ones, but again, if the value of a was higher, you will be able to see it better. Okay, now on the next video, we are going to learn how to graph the equation from a graph. So we will have a graph, and from the graph, we are going to write the equation. Stay tuned.